Lakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the harmonic analysis. This harmonic analysis having the base. Already we know that Fourier series formula, that is f of x equal to a naught a by 2 plus summation n equal to 1 to infinity a n cos nx plus summation n equal to 1 to infinity b n sin nx. So in this formula, for the harmonic analysis, we are expanding the summation. That is, first harmonic means we have to n equal to 1, we expand. And then suppose second harmonic means we expand the n equal to 2. Up to the number 2, we expand. So the formula, suppose second harmonic means we got this formula. So a1 cos x plus a2 cos 2x. Instead of n, we replace this 1 and 2. Okay, so likewise, b is also expanded here. So b1 sin x plus b2 sin 2x. So we got this formula. Here, we know already this a0, a1, a2, b1, b2. These values, if we know these Euler coefficients, we can calculate those values, and if we substitute here, we get the function value f of x. So how to calculate these not a1, a2, b1, b2, that and all. So we are having separate formula. I wrote this formula only for 0 to t5. Okay. So a0 means nothing else. Y is the summation y divided by n, and a is twice the summation y cos nx divided by n. And bn is twice the summation y sin nx divided by n. Here, our given sum is the x values are given as theta value, and then the corresponding y functions are given. So the corresponding f of x or as y, both are same. So y equal to f of x values are given. Then suppose for a convenient, it is given as the radian value. We can convert into theta value, means calculating in the calculator, it is very. Otherwise, we want to change the mode as radian. Okay. So next we can calculate this first value. So here a1 value means substitute a1 equal to summation y cos x. Only you get. So the numerator value we need to get. And then a2 means summation y cos 2x. So again for the a2 value, we need the second value. So y cos x, y cos 2x, these two values we need to calculate, and we need to calculate the summation value. Like this, all the summations we want to get. So how to get the summation values? So basically we want to know what are the values we need to calculate. So here x, y cos x. So how to get this y cos x? Simply this y value is given, and then instead of x replaced by 0 and y cos 0. That value is all. Next, y, that is 1.4 into cos 60. The value is 0.7. And then 1.9 into cos 120 is minus 0.91. 1.7 into cos 180 minus 1.7 we got. 1.5 into cos 240 minus 0.75. 1.2 into cos 300 we got 0.6. In our sum, that 0 and 36 lost value having the same degree, that is 360 degree. So we omitted the last one, and 1, 2, 3, 4, 5, 6. So 6 values we are having in the table. That's why n equal to 6 we got. Okay, only we need to calculate the numerator value. The numerator value we are calculating here. Same thing. Y into, that is y value is 1. Here cos 2x is given. So 2i is the number. And second one is 1.4 into cos 2 into 60, that is 120. If we know the value, multiply and write there itself. So cos 120 is energy. So cos 1.4 cos 120 minus 0.7. And then 1.9 into cos 240. That is, we are multiplying with 2. Okay. So here 240 degree we are calculating. The value is minus 0.91. Like this, we are calculating all the values. Same thing, we move on to this y value also. So y sin x, y value. For example, I am taking this one. Here theta value is 120. Here y value is 1.9. So 1.9 into sin 120. So 1.9 into 1 sin 120 is 1.645. Like this, parallelly, you want to calculate all the values. So all the values once calculated here, get the summation of each and every value. So after this, we move on to that calculating each and every constants. That is, first we calculate the A naught value. The formula is summation twice the summation y divided by n. So summation y value is 2 into 8.7 divided by 6. The value got 2.9. And then A1 value formula twice the summation y cos x n divided by n. So y cos x value is minus 1.1 we got. So write in bracket and then cancel these two and we got the A1 value. And then A2 means twice the summation y cos 2x divided by n. So twice the cos y cos 2x. That is minus 0.3 right here and get the value. And then V1, V2, likewise you get it and the corresponding value got. So all the constant values once we know means easily we can substitute instead of this A0, A1, A2, B1, B2. So in these 5 places I replaced here with this values. So this values are noted here. That's all. If we substitute, we got the function f of x. This 2.9 divided by 2 is 1.45 and then we can replace by this one. Okay.